This video looks at a few examples using the sum and difference of angle formulas, which there are 4 of. There's one for the sum of two angles using sine function, difference of two angles with the sine, and then the same for cosine. And the way that these work are, you have an angle for which you want an exact value for. So we've been doing some where it's like find the exact value of cosine of 30 degrees. We can do that from the unit circle. Sine of 45 degrees. Also unit circle finding. What we cannot do though from the unit circle directly is find examples of, say, find the exact value of 15 degrees, like the cosine of 15 degrees. That is not a number from the unit circle. Or, another one such as 285 shows up 105 degrees. Like what's the sine of 105 degrees? 105 is not something that's on the unit circle. But if we use, depending on whether they want sine or cosine, and we can break apart those angles given as either the sum or difference of two angles from the unit circle, then we can use one of these 4 formulas. So, the way they work is you break apart into alpha and beta, like 30 and 45 or 45 and 240. It just depends on what you break your sum or difference apart in. And then you'll pull from the unit circle the cosine and the sine of each of those numbers, which are exact, and you'll multiply them together and add or subtract depending on what the formula says. And then you'll choose accordingly based on whether it's sine or cosine and whether you did addition or subtraction. So here, let's do a few. So here's one that says find an exact value for the cosine of 15 degrees. 15 degrees is in the first quadrant. Our cosine value should be positive. So those are just some things to note. First quadrant, the sine should be positive. All right, so those are just some checks. So we need to take the 15 that we have and try to write it as either a sum or difference of two angles from the unit circle. Now, you can do this a lot of different ways. You could do, you can't add anything, but 45 minus 30, or you could do 315 minus 300, or you could do 150 minus 135. All those would get you the number 15 when you did the subtraction, but we want to stay in first quadrant, so we'll try to pick angles that leave us in first quadrant, and those are easier to work with. All the signs are positive. So we'll break apart 15 into 45 degrees minus 30 degrees, and we're still doing cosine. So for this one, we'll use the cosine difference formula that says cosine of one angle minus another, cosine of the first angle times cosine of the second, plus sine of the first angle times sine of the second. So that's what we'll pull from the unit circle. So if we do the cosine of 45 degrees minus 30 degrees, then we'll pull and do the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. All right? So in getting those values from the unit circle, the cosine of 45, which is just the x-coordinate, is the square root of 2 over 2. The cosine of 30 degrees is the x-coordinate, so that's the square root of 3 over 2, plus the sine of 45 is the y-coordinate at 45 degrees, so that's square root of 2 over 2, and the sine coordinate at 30 degrees is the y-coordinate, and that's 1/2. All right, so we have our values. Now we need to multiply, clean up, combine what we can, and give a final answer. So for the left fraction, I've got two fractions multiplying, so I'm just going to multiply straight across. That becomes the square root of 6 over 4. Same thing for the other fraction. I'm just going to multiply straight across. There's nothing to really simplify there. That would be the square root of 2 over 4. And since I have the same denominator, you could write that further as the square root of 6 plus the square root of 2 all over 4 for your final exact answer. You know, and of course your calculator in degree mode, you can type in cosine of 15 and get that decimal value for it. But when it asks for this exact answer, we'll go through, use the difference formula, and come up with an exact answer that's most likely a radical or a fraction form. All right, so there's cosine of 15 degrees. All right, next example has us find the exact value of sine of 345 degrees. So a couple things to note. 345 degrees is in quadrant 4. Because it's in quadrant 4, the sine value should be, because it's a y value, right? If it's in quadrant 4 down here, where the coordinate points are positive, negative, the sine value should be negative. All right? So we need to take the sine of 345 degrees and break that apart into either a sum or a difference of two angles. So we have options, 315 plus 30 and 300 plus 45 would give 345. They're both, one's in quadrant 1, one's in quadrant 4, but I think you could break it apart to either one that you wanted to. I'm just going to go with the 300 and the 45. So if I do the sine of 300 plus 45, then I'll end up using that sine of alpha plus beta sum of angles formula. And that one said I'd do the sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. And, like color coordination helps. By all means, please do so. So it helps you keep the values straight. All right, so we'll do sine of 300 degrees plus 45 degrees. So 300 is going to be our alpha, or our first angle A. 45 is going to be our second angle, beta or B. So this will be the sine of 300 degrees times the cosine of 45 degrees plus cosine of 300 degrees times sine of 45 degrees. All right? So from unit circle, we'll just plug in those sine and cosine values. Sine's the y-coordinate, cosine's the x-coordinate. At the 300 degree mark, the sine or the y-coordinate is negative square root of 3 over 2. The cosine of 45, which is the x-coordinate, is square root of 2 over 2 plus the cosine at 300 down in quadrant 4 is 1/2. Again, that's x-coordinate. And the sine of 45 degrees is up in quadrant 1, square root of 2 over 2. So it looks a lot like the first answer. If we multiply the fractions, we get negative square root of 6 over 4 plus square root of 2 over 4. And since they have the same denominator, you can write negative 6 square root of 6 plus square root of 2 over 4. Or if you wrote square root of 2 minus square root of 6 over 4, those are the same thing. So order of subtraction, addition, preference, it doesn't matter. But that should numerically give you the same thing as plugging in degree mode the sine of 345 degrees. And it will be negative. The numerator is a negative number. All right. So for cosine of 285, so again, just some notes. 285 degrees is in quadrant 4. Cosine value should be positive. Again, quadrant 4, where the points are positive, negative. Cosine is the x value. The answer should be positive. All right. So in trying to break apart 285 degrees, you could do 240 degrees plus 45 degrees. Or if you chose to do 330 degrees minus 45 degrees, 330, not 333. 330 degrees minus 45 degrees. Both of those would get you 285 degrees. And one is a sum formula and one is a difference formula. So I'd like to work through both of those to show you that it really doesn't matter which one you choose as long as you pick the right sum or difference that gives you the degree that you're trying to break apart. All right, so for the first one, I'm going to do, so we're doing cosine. So cosine of 285, I'm going to turn that into the cosine of 240 plus 45 degrees. And that will use my cosine sum formula that says I do cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. All right, so that's the sum of angle formula for cosine pulled from formula sheet. So when I do that, cosine of 240 degrees, that lives in quadrant 3. That's okay. The cosine is the x-coordinate at 240, which is your 4 pi over 3. The cosine value is negative 1/2. The cosine of 45, again, x-coordinate, square root of 2 over 2, minus the sine at 240 degrees, which is the y-coordinate of that angle in quadrant 3, is negative square root of 3 over 2. And the sine value of 45, again, y-coordinate in quadrant 1 is square root of 2 over 2. So, cleaning that up gives us negative square root of 2 over 4 plus square root of 6 over 4. I'm pretty sure that's the exact same answer that we just got on the last one. No, not quite. Looks really similar. So combining across the numerator would give us square root of 6 minus the square root of 2 over 4. That will be a positive answer, so we're good for sine. Or if you want to do negative 2 plus 6 in the numerator, it's the same thing. Again, just to do, to show some variety here, if I do cosine of 285 as the cosine of 330 degrees minus 45 degrees, that would use a difference of angle formula for cosine. And what that would be, again, pulling from my formula, is cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. So if we pull those values from a unit circle, the cosine at 330 degrees, which is in quadrant 4 at the 11 pi over 6, cosine as an x value pulls positive square root of 3 over 2. Cosine of 45, x-coordinate square root of 2 over 2, plus the sine of 330 degrees is the y-coordinate in quadrant 4 at that angle, so that's negative 1/2. And then the sine of 45 is square root of 2 over 2. So cleaning that up, we get square root of 6 over 2. And then I have a negative times a positive, and I'm adding. So the numerator is, so it's going to be a subtraction of the square root of 2 over 4. Should be over 4, not over 2. Sorry about that. 2 times 2 is certainly 4. And then subtracting across the numerator, we get square root of 6 minus the square root of 2 over 4. Again, same exact answer, but one used a cosine sum formula and the other used the cosine difference formula. But as long as you pick the correct two angles that either add or subtract from your unit circle to the angle that you're trying to find the cosine or sine function value for, you should come out with the same answer either way.